Unified nowcasting. Well, it sounds very mysterious, but I'm going to try to walk you through what this is all about and why we did it. So we're going to start a little more generic and talk about how we do weather forecast processing at Palmerex in general. And this will give you an idea of any type of work we do, how we do it. So I want to start by looking at this overview, and it gives you a sense of the workflow and the overall value chain in weather content. What we do is we take in a content feed. That could be a weather station piece of information, could be radar data, it could be a computer model. We take that in, we bring it in-house, we do something with it within the Palmerex factory, and then we ship it out to the consumer. In the case of unified nowcasting, there are two key data sets: radar as well as computer models. So in this case, a computer model, numerical weather prediction model from the US. And it's this content that dictates where we can do things, basically. And it's why this project was applied to Southern Canada and the US, because we have the data to support it. So let's go ahead and now talk about what a nowcast is. A nowcast is a part of the forecast that's between the current time and the first 6 hours. So it's essentially what's happening now, and you're casting that into the future. And it's a tricky window because it's a time when observations do better at the very start, but computer models do better at the end. And the trick is figuring how to blend those two things together. And weather providers really struggle with this window. Here's an example of the same time for a forecast, actually different forecast, but they show you the weather network. This is the weather channel. This is AccuWeather. And in all these cases, you're getting a difference between a start-stop product as well as the hourly forecast. 9:40, well, it shows 12 a.m. there. This says 94 minutes from now, and that timing doesn't line up. So in all of these cases, providers struggle, which is why we did this forecast. And how we improve things, well, we took, in this case, and this graph is just showing you skill on the y-axis versus time on the x. You want to be as high as possible. So we took the best of both worlds. Radar extrapolation is the red line, great at the start, bad at the finish, with this high resolution rapid refresh model, not too great at the start, pretty good at the finish, and combine them together into a unified nowcast, giving you the best of both worlds and actually beating either of those at any given time. So that's the overall idea of what this project is all about. And I think the best thing to do is really take a look at an example of how this works. And in this case, it was an example from a tropical storm. This was Alberto back in May. And what we've done here with unified nowcasting is, remember, take two data sets, radar and a computer model, and blended them together. And look what it does. Radar is over land, the computer model is over the Gulf of Mexico. This is not radar, but it looks like it because of the elegance of the solution in blending these two data sets together. You can actually see a little bit of a break there where we're stitching things together. That's the elegance, the beauty of this solution, is that we've now got a harmonized, unified data set for predicting precipitation. We've also layered on the meteorologists so they can influence how this data gets used, because it's not always going to be what you want, because these data sets can go off the rails. Hopefully that gives you an idea of what unified nowcasting is all about.